Hello everyone, welcome to my channel. So we'll continue the series of the derivative. So last day we have done some problems of substitution. Now we'll continue that one. Okay, so next this is question number. So this is the first question of the day. Question number 1. The question is like this: sec x plus y divided by x minus y equals to a, then prove that dy dx equals to y by x. Dy dx equals to y by x. So this one is the first one for today. So it is given sec x plus y by x minus y equals to a. We have to prove that dy dx equals to x y by x. Now how to do this one? First of all, we can see there is a sec and here it is a constant. So if the sec goes there, it will become like this: x plus y divided by x minus y, that will be sec inverse of a. So x plus y by x minus y, that will become sec inverse of a. Now if I differentiate this one with respect to x, what will happen? So I am differentiating x with respect to x both sides. So now look at this. This is a u and v by u by v form. So this is a division form. So here you have to apply that formula. So what was the formula? So whenever there is a u by v form, the formula will be v du dx minus u dv dx divided by v square. So that was the formula for u by v. Now here you can see this is the u and this is the v. So there the formula will be x plus x minus y into derivative of d dx of x plus y minus, now the opposite one. Now x plus y will be the constant one. We have to differentiate x minus y. So that will be x minus y whole divided by v square. That means x minus y whole square. And now look at this. A is a constant, so sec inverse a also being constant, so the differentiation of that one will be 0. So this one. Now in the denominator we can see there is a x minus y whole square. Now if it goes there, it will become 0. So what will be the result? Then it will be x minus y into, now look, we have to differentiate x plus y with respect to x. So differentiation of x will be 1 and differentiation of y will be dy dx. So that will be 1 plus dy dx minus, again it will be x plus y into, so differentiation of x minus y, that means differentiation of x, that will be 1 and differentiation of y will be dy dx. So that will be 1 minus dy dx like this, and it will be equals to 0. So now from here we have to somehow find the value of dy dx. Now if I multiply, just simplify this one: x minus 1 into x minus y into 1, that will be x minus y plus, now this x minus y will be multiplied with dy dx. So that will be x minus y dy dx minus, again multiply this one with 1, so that will be x plus y, and again this one will be multiplied with minus dy dx. So again we can see minus and minus, that will be plus x plus y, that will be dy dx equals to 0 like this. Now we can see here, from here we can see there are, here these two are dy dx, so we can take dy dx common from here. If I take dy dx from these two, that will become, look, here it is x minus y, it is x minus y, and here it is x plus y. So here we can say this is x plus y, so that will be x plus y. And what are the remaining elements? Here you can see x minus y, and if the minus is multiplied with this one, that will be minus x and minus y equals to 0. So you can see x and x cancel out. So here also you can see y and y cancel out, so it will be dy dx into 2x and here it is minus 2y. If it goes there, it will be 2y only. So it will be dy dx equals to 2y by 2x. So 2 and 2 cancel out, it will be y by x. So dy dx will be y by x. So this is the proof here. So here we have to prove dy dx equals to y by x, and we can see here dy dx equals to y by x. So this is the proof. So this is the way to prove this problem. The next one, so now today we'll do the important one. So next one will be question number 2. So question number 2, you can see. So in the question number 2, it is given sin y equals to x sin a plus y, x sin a plus y, and we have to prove dy dx equals to sin square a plus y divided by sin a. So now it is, so here you can see sin y equals to x sin y a plus y is given. We have to prove dy dx equals to sin square a plus y by sin a. Now how to prove this one? Now you can see here, this is a y, here it is also y, and it is a x. So first we will separate x and y. So how to separate this one? First it will be, look, it will be sin y, and if it goes there, it will become by sin a plus y equals to x. Okay, so this is x equals to this one. Now here, so you can write like this, x equals to sin y by sin a plus y, like this also you can write. Now here you can see this is a y, the right hand side is here y and the left hand side is here x. So now we will differentiate with respect to y both side. Okay, now differentiating with respect to y both side. So here we are differentiating with respect to y both sides. So that will be, on the left hand side you can see there is x, so that will be dx dy equals to, now on the right hand side you can see this is again u by v form. This is u and this is v. So what will be the formula? Now v will be constant, that means sin a plus y into derivative of the u. Now here what is u? Sin y. So since this is a derivative with respect to y, so derivative of sin y will be cos y. So that will be cos y minus, now sin y constant, derivative of sin a plus y, so it will be cos a plus y divided by the numerator square. Now you can see the numerator is sin a plus y, so that will be sin square a plus y. Now look at the numerator now. Now look at the numerator. If I see the numerator here, it is sin a cos b minus cos a sin b formula. So what was the formula? Sin a cos b cos a sin b. The formula is trigonometry formula, that is sin a minus b, like this. Sin a cos b minus cos a sin b. The formula is sin a minus b divided by, it is sin square a plus y. So we can see y and y cancel out. So this is my dx dy. But I need to find the value of dy dx. So if I reciprocal this one, that will be dy dx equals to, that will become sin square a plus y divided by sin y. Okay, so that will be the proof. Here this one we need to prove. Look here, dy dx equals to sin square a plus y by sin a, that we need to prove here. So this is the answer. Now this is a way to do this type of problems. Okay, now next one, question number 3. We move to question number 3. Now this is very interesting one. 3 equals to, question number 3. So the problem is like this, y equals to, it is given root over of tan x plus again root over of tan x plus again root over of tan x plus dot 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 up to infinity. Okay, so y equals to given root over of tan x plus root over of tan x, and like this up to infinity. We have to prove, so prove that 2y minus 1 dy dx, 2y minus 1 dy dx equals to sec square x. This one we need to prove. So from here we can see, now from here, so how to solve this type of problem? It can be also written root over of sin x plus sin x, root over sin x, like this. So how to solve this type of infinite problems? So first of all, we can see there are root, square root and so on. So first we have to square both sides. So I'm squaring both sides. That means the first root will be removed. It will become like this: tan x plus root over of tan x plus root over of tan x plus dot 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 infinity. So how many tan x are there? So here there are infinite tan x, and here also you can see there are infinite of tan x. So the value of that infinite tan x was y. Here also, since this is the same thing, here it will also be tan y. That will also be, the value of this one will also be y, because look at there, it will be tan x tan x tan x up to infinite tan x is there. Here also you can see tan x tan x tan x up to infinite tan x. So both are same. So whatever the value of this one will be the value of this one also. So that is also y. Now differentiate this one. If I differentiate this one, y square with respect to, now with respect to x, I am differentiating, so that will be 2y dy dx. Okay, and differentiation of say, tan x will be sec square x, and this one y will be dy dx, like this. Now if the dy dx goes there, okay, if the dy dx goes there, that will be 2 dy dx minus dy dx equals to sec square x, like this, sec square x. Now from this two we can see dy dx is a common, so we can take the dy dx from here, so that will become 2y minus 1 dy dx equals to sec square x. So that will be 2y minus 1 dy dx, that will be sec square x. So that one came. So this is the proof here. Okay, proof. So this is the proof here. So same way we can do the same sum. Suppose there is a sum, this is a homework you can do. Same thing, y equals to root over of sin x plus root over of sin x, okay, and root over of sin x plus dot 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 infinity. Then how to find dy dx? Okay, same thing, same procedure. So whenever this type of problem came, first we have to, since there is a square root, we have to square both side. So then first square root is removed, then it will go like this. Okay, this is the way to solve this one. Now next is question number 4. This is the important type also. Question number 4. Now this is a type of variable to the power variable. Whenever there is a variable to the power variable, how to solve this type of problem? For example, what will be the derivative of, suppose y equals to, it is given x to the power cos x. Now how to find the derivative of this one? How to find dy dx from here? Okay, so how to find this one? So number one, first, whenever there is a, look, this is a variable and the power is also variable. So whenever this is a variable to the power variable, first what we need to do is that we have to take logarithm both sides. That means it will become log y equals to log x to the power cos x, like this. Okay, so since this is a variable to the, whenever there is a variable to the power variable, what we need to do is that we have to take logarithm both sides. So from here you can see, if I take logarithm both sides, it will be log x to the power cos x. Now this is the power x to the power cos x. So there is a power, so there is a property of log. So what was the property? If log it is a to the power b, it can be written as b log a. Okay, b log a. So if there is log a to the power b, the property is we can write b log a, like this. So here also you can write like this, that will be cos x into log x. We just use the property of logarithm. Now we have to differentiate with respect to x both side. Now if I differentiate this one, the derivative of log y will be 1 by y, and chain rule, use the chain rule. Now here it is y, we are differentiating with respect to x, that will be dy dx, and here you can see this is a u and this is a v, so u v form. So cos x, derivative of cos x will be minus sin x into log x plus cos x into differentiation of log x. The differentiation of log x is 1 by x. This is the product formula. What is the product formula? First one will be constant and next one derivative. Look here, so cos x into log x, there are two functions, one is cos x, one is log x. So first log x is constant, derivative of cos x, that is minus sin x, plus now opposite one, cos x is constant, derivative of log x, that is 1 by x. Now from here we can write dy dx, if y will go there, that will be y into cos x by x minus sin x into log x, like this. Okay, now we know the value of y. What is the value of y? X to the power cos x. So just put the value here. So that will be dy dx equals to x to the power cos x into cos x by x minus the value of sin x into log x, that is sin x into log x. So that will be the answer, like this. So whenever a variable to the power variable will come, what we need to do is that we have to first take the logarithm both side, then using the property of logarithm we have to solve this one. Okay, this is the way. Now next one, using that one only. So I'm giving another question here. Suppose it is given, suppose one question is given like this, number 5, this one. Wait. So here first it is given, suppose x to the y equals to x to the power cos x, not x to the power cos x, take any other value. Okay, y equals to cos x to the power x, suppose cos x to the power x plus sin x to the power cos x. Suppose this type of thing is given. Now from here we have to find the differentiation. What is dy dx? We have to find. Okay. Now from here, how to find dy dx? From here we need to find dy dx. Y is given what? Cos x to the power x and plus sin x to the power cos x. Now from here we need to find the value of dy dx. Now how to find this one? Look, so first of all, here this is variable to the power variable, here it is also variable to the power variable, but there is a term plus is there, so there is one plus is there. So first of all you have to differentiate differently. That means first, what will be the solution? First we have to take the first part as u, that will be cos x to the power x, and the second one as v, and the v will be here. What is the second part is here? Sin x to the power cos x. So that is sin x to the power cos x, like this. Now look at this. Now here we have to differentiate separately. So first we can say there is u equals to cos x to the power x, so variable to the power variable. So how to solve this? So you have to take logarithm both sides, that will be log u and that will be log cos x to the power x, like this. Now we can see again the property of log. So the power is here x, so that will be x log of cos x, like this. And here in the LHS it will be log u. Now differentiating both sides, what will come? So log u means that will be 1 by u into du dx, okay, equals to, now look at this, this is u and this is v. Now differentiation of x will be 1 into log cos x, like this, plus x into differentiation of log cos x. So what will be the differentiation? That will be 1 by cos x into cos x differentiation will be minus of sin x. So again we can see that will be du dx, u will be multiply here. Okay, now u will multiply here, you can see. Now what is the value of u? The value of u is cos x to the power x. So directly I'm just putting the value here. So that will be cos x to the power x, and it will be log of cos x and that will be minus x sin x by cos x will be tan x, like this. So this is the part 1. Okay, so this is equation 1. The next one is again v. What is v here? V is given sin x to the power cos x. So v here it is given sin x to the power cos x. Now how to solve this one? Sin x to the power cos x. Again the same thing, variable to the power variable. So I have to take logarithm both sides. So that will be log v, and that will be log sin x to the power cos x. Now again you can see this is variable to the power variable, so the property of log, so that will be cos x into log of sin x, like this. Now if I differentiate, that will be 1 by v, this is log v, so it will be 1 by v, and that will be dv dx. Again it is uv form. So what is the uv form? The differentiation of cos x will be minus sin x, and log will be remaining constant, that will be log of sin x plus, now cos x is constant, into differentiation of log sin x. So differentiation of log will be what? 1 by sin, and differentiation of sine will be cos x. So again what will be dv dx? The dv dx will be now we can see v here, v will be multiplied, and we know the value of v, this is the value of v, so that will be sin x to the power cos x. Okay, multiply, that will be minus sin x into log sin x plus, we can see cos x and cos x multiply, that will be cos square x into 1 by sin x can be written as cos x square x, like this. Okay, so this is the value of dv dx. Now what was the question here? The question was y equals to this one plus this one. Now here you can see, so from here you can see y equals to what? This is we have taken u plus the next one you have taken v. Now if I differentiate this one, dy dx will be what? Dy dx will be du dx plus dv dx. Now we know the values of du dx and the value of dv dx. So here this is the value here, du dx, the value of dv dx is here. So you just have to put the values here and get the result. Now here you have to just put the value, here you have to put the value and we will get the result here. Okay, here just put the values and we will get the result, like this. So this is the way to solve this type of problems. Whenever the variable of power is variable and there is a plus or minus in between them, so this is the way we can solve it. So you have to take a separate function for that one, then you have to solve this one. Okay, so we'll solve so now next one, so this is question number 5. Now next one will be question number 6. So how to solve this one? Question number 6 is given like this. Question number 6, so it is given y log x equals to x minus y. It is given. Now we have to prove here dy dx equals to log x by 1 plus log x whole square. This we need to prove. Now how to prove this one? Now look at this. Here you can see this is y log x and there is a x minus y. So first of all, this y will come here. What will happen then? That will become y log x plus y equals to x. Now from these two, what is the common here? We can take y and it will become log x plus 1 equals to x, like this. Okay, now if 1 plus log x goes there, it will become y equals to x by 1 plus log x. Now it will be very easy. Y equals to this one. Now we have to differentiate this one. We can say if I differentiate with respect to x, that will be u and that will be my v. So u by v formula. So here we have to use u by v formula. So left hand side is y. So differentiation of y with respect to x will be dy dx equals to. Now look at here, this is u and this is v. So first, what is the formula? V will be remaining constant. We have to differentiate the u. So what is the u here? X. So differentiation of x will be 1. minus, now x will be remaining constant, we have to differentiate the v here, so that will be 1 plus log x, differentiation will be 0 into 1 by x, 0 plus 1 by x, okay, and divided by the denominator square, that means 1 plus log x whole square. Now we can see here it is coming 1 plus log x minus x into 1 by x, so x cancel out, so it will be 1 plus log x whole square in the denominator. So in the numerator you can see there is a 1 and there is a minus 1, so 1 and minus 1 will be cancelled out, so it will only be log x divided by 1 plus log x whole square, and hence this is the proof. So dy dx equals to, it is log x by 1 plus log x whole square, it came, so hence it is the proof. So this is the way to solve this one, okay. So this is the question number 6, this is the way we can solve this. Now question number 7, move to question number 7. So in question number 7, what is given? So in question number 7, the question is like this, it is given log y equals to log 2x minus 3, and suppose this is x. Now from here we have to find dy dx. Now how to solve this one, this type of problem? So here you can see it is log 2x minus 3 and here it is log x. Now for this one you need to know of property of log. What is the property of log? If there is log a base b, suppose there is a log a base b, that one we can write like this, log a by log b, like this, okay. So here also you can write y equals to, you can see log 2x minus 3 and the base is here x, so we can write like this, log 2x minus 3 here, and what is the base? The base will be e, suppose, and here it will be log x base e, like this, log 2x minus 3 divided by log x, like this we can write. Now it become easy. So here you can see this is a u and this is a v. Now if I differentiate this one, that will be a u by v formula. So differentiate this one, that will be dy dx. So the same formula. What is the formula? First it will be v will be, that will be constant, that means log x base e, that will be constant, and differentiation of this one, log of 2x minus 3 base e, minus, now the opposite one, that means log 2x minus 3, that will be constant, we have to differentiate that log x, we have to differentiate log x, divided by log x whole square, log x whole square. Then now use the formula here, so that will be log x, it will be log x into differentiation of log 2x minus 3. So the differential log is, we know, 1 by x, that means differentiation of that one will be 1 by 2x minus 3, 2x minus 3 into the chain rule. Chain rule means you have to differentiate that one also, 2x minus 3. So 2x, the differentiation of x is 1, so that will be only 2, that will only be 2, minus again it is log 2x minus 3, and differentiation of log x is 1 by x, so that will be log 2x minus 3, log 2x minus 3 base e into 1 by x, like this. And here the denominator will be log x base e whole square, log x base e whole square, so that will be 2 by 2x minus 3 log x minus log 2x minus 3 divided by x whole divided by log x base e whole square, like this, okay. So now you can simplify this one and that will be the answer. So this is the way you can solve this type of problem. So whenever this type of problem, log 2x minus 3 by x, so first you have to use the property of log a base b, and then you have to differentiate, okay. So I'm giving an exercise here, homework, like this. Find this one, log cos x base sin x. Okay, y is given. So find the differentiation of this one, dy dx. What will be the value of dy dx? From here we have to find. Now next one, we have done the variable to the power variable. Now parametric form. Okay, so parametric form, number 7 8. So what is parametric form here? So number 8, suppose this type of thing is given, question number 8, parametric form this type. How to solve this type of parametric form? Suppose x is given here, uh, this is x is given, a into theta plus sine theta. So this is my x, and y is also given. Y is given here, y is given a into 1 minus cos theta. Now from these two we have to find dy dx. Okay, so this is the parametric form. X is given, y is given. Now from this we have to find the dy dx. Now how to solve this? So first of all, look at here, what is the parameter here? Here it is theta, here also it is theta. So x equals to, it is given in theta and y is also given in theta. That means first what we need to do, what is the sketch here? First we have to find dx d theta, and then you have to find dy d theta, like this. Since here the parameter is theta, if the parameter was t, we have to find dx dt and dy dt, like this. Now what is the next step? We have to find dy dx. So how to find dy dx? Dy dx can be written as dy d theta by dx d theta. So that means whatever value of dy d theta was there, we have to put here, and whatever value of dx d theta was there, we have to put here, and we get the result of dy dx. Now solve this one. So x is given, so x is given a into theta plus sine theta. Okay, so here we can see x is given theta plus sine theta. So first we have to find dx d theta. So how to find a? Now derivative of theta is what? 1, and derivative of sine theta is given cos theta, like this. So dx d theta will be a into 1 plus cos theta. Now next one is y. So what is y? Y is given a into 1 minus cos theta. So we can see y is given a into 1 minus cos theta. Now if I differentiate this one, dy d theta, what will be the result? A into differentiation of 1 will be 0, and differentiation of cos theta will be minus sin theta, that will be plus sin theta. So here you can see it is a sin theta. So dx d theta and dy d theta is like this. Now next one, what we need to find is dy dx. So dy dx will be what? Dy dx will be dy d theta by dx d theta. So what is the dy d theta here? What is the value of dy d theta? Here you can see the value of dy d theta is here a sin theta, and value of dx d theta is this one, a into 1 plus cos theta. So this is a sin theta divided by a into 1 plus cos theta, like this, and a and a will be cancelled out, so that will be the result. So dy dx will be what? So here dy dx will be sin theta by 1 plus cos theta, like this. Okay, so whenever this type of parametric form is given, x is given, y is given, so first we have to find dx d theta or dx dt, depending on the parameter is there on the right hand side, then dy d theta, and then divide that one, will get the value of dy dx. Okay, like this. Suppose another problem I am giving, that x equals to, try to solve this one. Okay, this is the exercise. So this is the exercise. It is given x equals to a into cos theta plus cos 2 theta. Okay, and y is given this, y is given a into sin theta plus sin 2 theta. Okay, these values are given. From here find dy dx. Okay, from there we have to find dy dx, like this. Okay, this same thing, x is given, y is given, and we have to find dx d theta, then dy d theta, then use the same thing as we have done here. We can find the value of dy dx. Now next question is question number 9. So we'll solve question number 9 here. So number 9, question number 9. So the question is given like this. X is given, suppose this type of, now this type of thing is same. So the question is here, find differentiation, find the differentiation of sine x with respect to x square. Now this type of problems, okay, this is similar to the previous one also. Okay, in the previous one it is given x equals to that, y equals to that, but it is not given directly. So here what is asked, we have to find the differentiation of sine x with respect to what, with respect to x square. So that means here also two variables are given, one is two functions are given, sine x and one is x square. So I am letting the first one as y, that is sine x, and the second one as x square is as z. Okay, so the first one I am letting as y and the second one I am letting as z. Now what we need to find is here, we have to find the derivative of this one, sine x with respect to x square. That means we can also write, we have to find the differentiation of y with respect to z. That means we have to find dy dz from here. So same logic. So y is here, you can see in terms of x, and z is also in terms of x. So what we need to do is that we have to first find dy dx, then we need to find dz dx. Okay, so this is a sketch. So first we have to find dy dx, then dz dx. Next step we have to find dy dz. That means that will be dy dx divided by dz dx, like this. Okay, so this is the next step. So same as the previous one. In the previous one it is given directly, but here it is not given directly, we just have to let that one. So y is given sine x. So first what we need to find is dy dx. Now you can see y is here sine x, so dy dx will be what, cos x, and z is also given, so what will be dz dx? So you can see here z is given x square, what will be dz dx? Dz dx will be 2x. So now we have to find dy dx. That means it will be, sorry, we have to find dy dz now. So that means we have to find dy dx by dz dx. Okay, so here it will be cos x by 2x, like this. So that will be the answer. Okay, so this is the similar as the previous one, but there it was given directly, but here it is not given directly. So do this one, question number 10. So we'll solve the next one, question number 10. So the question is like this. Again, it is given. We have to differentiate tan inverse. We have to differentiate tan inverse root over of 1 plus x square minus 1 by x. Okay, we have to differentiate this one with respect to tan inverse x, with respect to tan inverse x. So this is a question. So here again same thing. So it is given that we have to find the differentiation of this one with respect to this one. So first what we will do, we have to let the function as y and z. So I am letting y equals to tan inverse root over of 1 plus x square minus 1 by x, and z equals to tan inverse of x. Then now we have to find dy dx and dz dx. So here look at here properly, here look here. So tan inverse of this one, how to find differentiation of this one, we have done in the previous class also. So how to find the differentiation, this is the, here you have to use a substitution. Now you can see there is a 1 plus x square. So whenever 1 plus x square, in the previous class I told that one, that whenever there is 1 plus x square, we have to take x equals to tan theta. So how to solve this one? First here to solve dy dx, here we have to let x equals to tan theta. So this is a mixture of substitution and this one. Okay, so what will be y then? Y will be tan inverse of root over of 1 plus x square, that means 1 plus tan square theta minus 1 divided by the numerator. Look at the numerator, x is here, tan theta, like this. Okay, so now we can see it will become tan inverse 1 plus tan square theta, and that the root. So 1 plus tan square theta is sec square theta. The root will become sec theta minus 1 whole divided by tan theta. Now tan inverse of, here you have to, now we can see there is sec theta, tan theta, to convert it to sine or cos, sine and cos. So sec theta can be written as 1 by cos theta minus 1, and tan theta can be written as sine theta by cos theta. Now do the LCM and simplify this one. This will come like this: y equals to tan inverse of, it will become like this, 1 minus cos theta by cos theta. Okay, so that will come like this: 1 minus cos theta by cos theta, and there is divided by sine theta by cos theta. It is coming sine theta by cos theta. We can see cos theta and cos theta cancel out, so that will be tan inverse of 1 minus cos theta by sine theta. Now 1 minus cos theta, now we know the formula here. I have given the formula: 1 minus cos 2 theta equals to what? 2 sine square theta. That was the formula. So what will be 1 minus cos theta then? Now look, if the angle is 2 theta, it is becoming half. So here also the theta will becoming half. That means 2 sine square, it will be theta by 2. So 1 minus cos theta will be nothing but 2 sine square theta by 2. So that is 2 sine square theta by 2, and in the denominator we can see sine theta is there. So what is the sine theta? Sine theta can be written as 2 sine theta by 2 into cos theta by 2, like this. Now 2 and 2 will be cancel out, 1 sine will be cancel out, so that will be sine by cos, and whenever there is sine by cos, the answer will be tan theta by 2. So that will be y equals to tan inverse of tan theta by 2. So tan inverse and tan, so you can see, you can write like this: theta by 2. Okay, so y is here theta by 2. Now what is the theta here? We can see from here what is the theta. So theta will be tan inverse of, so here you can see theta is tan inverse of x. So y equals to, theta means tan inverse of x, and this is by 2. So y equals to tan inverse of x by 2. Now we have to differentiate this one. So how to differentiate? Dy dx will be half into tan inverse of x. The differentiation will be 1 by 1 plus x square, like this. Okay, so half into 1 by 1 plus x square. And now look at here, this will be a now next function is tan inverse x. So this is easy, so we have let this one as z. So what is dz dx? From here we can only write dz dx is 1 by 1 plus x square. Then now we have to find the differentiation of this one with respect to this one. That means we have to find dy dz. So we have to find dy dz, and what is dy dz? From here we can write dy dx by dz dx. Now if dy dx is this, we can write like this: what is the dy dx? Half into 1 by 1 plus x square. And what is dz dx? 1 by 1 plus x square. Now this one will be cancelled out, so the answer will be here half. So here we can see dy dz is coming half, so that will be the answer. Okay, so this is the technique to do this type of problems. So in this video we have done this type of problems. In the next video we'll done the second derivative formulas. Using the second derivative we'll solve some problems that will be important from the exam purpose. Okay, thank you for today.